Gram formula mass of NaCl. Does anyone know what gram formula mass means? Logan. That's it. Very good. It's the mass of both of them added together. So how would we do that? What are the two numbers we're adding together?
23.
So 23 for the Na plus
35.
35 for Cl. That's 58 grams per mole. Okay, if you need to write this down, write it down. If you don't, then you don't. But this is how we find the gram formula mass. The mass of the element on the chart is the gram formula mass. That mass tells us the mass of 1 mole. We talked about moles a little bit earlier in the year. We're going to start using them again here. So it's important that you understand the relationship between the mass on the chart and moles. It's called gram formula mass. So you would add them up. That equals 58. So if I was holding 58 grams of salt, I'd be holding 1 mole of salt. Okay, 1 mole of salt. Does this ring a bell of some sort? Hopefully. Okay. Good. So you need to have a relationship, understand the relationship between grams and moles before we move on here. So now, if we know this is the gram formula mass of salt, and I ask you a question, how many moles of NaCl are present in 100 grams? We should be able to answer that. So I want you to write that down. If we know the gram formula mass of NaCl is 58 grams per mole, we know that. So now we should be able to answer the question, how many moles of NaCl are present in 100 grams? So if I have 100 grams of NaCl, I have more than 1 mole because 1 mole has 58 grams. So I'm going to give you a minute. And if you need a calculator, you can come get it. We're going to need them anyway. Should. No? Okay.
No, you are.
This is why the term gram formula mass is important, and you understand what it is and how to find it, so you can answer questions like this. Okay, who has it? Max does. How'd you get that? Set up a proportion for me. That's how I teach, so I'm going to do it that way. Show me how to answer this using a proportion or a ratio. Remember, stoichiometry means ratio, so there's a method to my madness here. How about I help? If 58 grams are in 1 mole, finish the ratio. If 58 grams are contained in 1 mole, 100 grams in X. Very good. Cross multiply and then divide. So what you did is right. Very good. And you don't have to do it this way, but this is how I teach it, and I think it helps some students, visualize a little bit better. This was our, bless you, this was our gram formula mass from the chart. So I know this is a constant. The question changes that constant. We don't have 58, we have 100, so the moles are going to go up. Bless you. cross multiply, 58x equals 100, divide by 58, divide by 58, x equals 1.7 what? 1.72 moles. 1.72 moles. Okay. Questions? All right, I'm going to assume, even though that's not too smart, that we are good with this, so we're going to move on because I saw that you've already worked on this type of stuff. So if you're not okay with this, you've definitely got to take responsibility for your own learning, so I can't read your mind, and let me know. Come see me and say, I can't do that. If you can, I'll teach you, but we're going to move on. Here we go. So stoichiometry. Okay. Stoichiometry, basically, let me kind of summarize it, is using mole ratios in balanced equations to determine relative amounts of reactants and products. And that may not help. That may make it more confusing, but that's a basic way to explain it. You're using mole ratios and balanced equations to determine how much reactants or products we have, or how many particles of, or how many reactants, how many products we have or need. So I'm going to take a few minutes to kind of explain this, give you an example, and then I got a worksheet. Might be a little soon for the worksheet, but we'll try it anyway. Worksheet for homework. Some of you might get this pretty quick. Some might take a little longer. That's okay. Just depends every year. It's kind of random on how fast we get through it. Okay, so let's use an example everybody knows and everybody likes. Pancakes. How do we make pancakes? You don't like pancakes? You hate pancakes? Oh, you can't eat gluten. Let's say we have gluten-free pancakes then. All right, so we have gluten-free pancakes for Marcy. Let's make gluten-free pancakes from scratch. What do we need? Milk. So we need milk. What else do we need? Flour. Is that where the gluten comes from? So we're going to get gluten-free flour. Gluten-free flour. Okay. What else do we need? Eggs. Yep, eggs. Need eggs. What else do we need? Is that basically it for like bare minimum, right? I think I don't make these things from scratch. I use the thing because it's the stuff. Well, I guess the stuff is this, but all right. Let's make apple pancakes. Because I really like apple pancakes. We need apples. Okay. Let's say we want to make 20 pancakes. How many cups of milk do you think we need? 5 cups of milk? Nope. Good try. That's a lot. How about 2? 2 cups of milk. How many cups of gluten-free flour? Yes. 4? I don't know. Seems like a lot. Let's go. We'll go with 4. Okay. How many eggs? 3? 2. 2 eggs. How many apples? 10 apples. All right, 10 apples. That's going to be basically just a bunch of apples with a little bit of other stuff. And the result is 20 pancakes. Okay. There's a method to my madness here. Second time I said that. These numbers, this is just like a real life example, sort of. But these numbers represent moles. So if you have 2 moles of milk, 4 moles of gluten-free flour, 2 moles of eggs, 10 moles of apples, you're going to get 20 moles of pancakes. The reason I use this example is because everybody can understand. Let's say we wanted to make 40 pancakes. What would we have to do with all of our ingredients? Double them. What if we only wanted to make 10 pancakes? We have to cut all our ingredients in half.
them by 2.
What?
So divide them by 2.
Divide them by 2, right. What if we wanted to make 4.5 pancakes? Could you do the math and figure out how many apples I need for 4.5 pancakes? If you know 10 makes 20, do you feel confident you could figure out how many apples you need for 4.5 pancakes?
Why would you make half a pancake?
You wouldn't. But this is I'm slowly getting us towards what we need to learn here. This is what stoichiometry is. I give you a balanced equation, or you balance an equation, and then the question changes that. So the question says, all right, if I want 10 moles of product, how many moles of eggs do I need? Or whatever that reactant is. If I want 2 moles of product, how many moles of this reactant do I need? So it's all about ratios. So if I wanted 10 pancakes instead of 20, and the question wants to know how many cups of flour, I would do a ratio or a proportion. I would say 4 to 20 is X to 10. So 4 gives me 20 pancakes. How many cups will give me 10? Cross, multiply, divide, right? And then obviously it's going to be 2. That's easy, but it's not always going to be that easy. So this example is, I think, easy to follow, but that's all stoichiometry is. It gets confusing because this isn't going to be milk and eggs and apples and pancakes. It's going to be copper sulfate, silver nitrate, ammonium hydroxide, sodium chloride. It's going to be, chemicals, but it's the same concept. You get your balanced equation, set up a proportion, and then answer the question they're asking. How's that sound? Like fun on a birthday? Let's try one real example now, not with pancakes, and see how we do. All right. So we'll start out with a pretty simple example. Let's go with magnesium plus oxygen yields magnesium oxide. Go ahead and write this down. We need 2 of those and 2 of those. So here's my question. So you go ahead and write that. Here's my question. How many moles of oxygen gas are needed to produce 3 moles of MgO? So you're given the balanced equation. You know the mole ratios. It's 2 moles of Mg, 1 mole of O2, 2 moles of MgO. Then the question changes that. The question wants to know, all right, what if I don't want to make 2 moles here, I want to make 3? I'm going to have to change my ingredients, right? Like the pancake analogy. I have to change the amount of reactants if I want to change the amount of products. That's where the ratio comes in. That's where the proportion comes in. Because in the original equation, 1 mole produces 2. I want to know how many moles are needed to produce 3. You probably don't need a calculator for this, but maybe. Who thinks they know? Who knows? What's the answer? How do we find it? Nobody knows. Nobody wants to share. gearing up? Go ahead. How many? 1.5 moles. Let's find out. The ratio is 1 to 2. So 1 mole of O produces 2 moles of MgO. Right? 1 to 2. How many moles produce 3? Cross multiply. 2x equals 3. 2x equals 3. Divide by 2. Divide by 2. X equals 1.5 moles. Yes, very good. Correct. 1.5 moles. So, I'm out of time. Good job, Hannah. I'm going to give you a worksheet where you're doing this. More of this. I know we only got one example, but I think you can handle it. Listen to tomorrow. Last question, 3B, is challenging because it's asking about grams, not moles. Give it a shot. We'll go over it tomorrow. It's more of the same. So use that example to do this worksheet.